Hi, this is Dr. Eddie Morgan over at Clovis East High School, ready to help you with your homework again tonight. Tonight in Math 1, we'll be looking at worksheet 9.1b. Remember, every problem on the homework help mirrors a problem on your homework. So if you have a problem with just one or two problems, fast forward to those problems and we should be able to help you out. Let's get started. First couple of problems ask us to find the circumference of each circle in terms of pi. Well, our formula for the circumference of a circle is that the circumference equals 2 pi r, where r is the radius. And in this case, in our first problem, here's our radius r. Is how far is it from the center to the outer circle? So we just plug in 3/4 for r, and then we simplify it. 2 times 3 is 6 divided by 4 is going to end up being, you notice the 2 goes into the 4 2 times, so I end up with 3/2 pi m, and it told us to leave it in terms of pi, so that's our answer, 3/2 pi times the meters. In the second one, you notice we have the diameter here. Now what we want is the radius, which is halfway, and so one way to do this problem is simply to take the diameter and cut it in half. So the radius is half the diameter, so our radius is going to be 14 divided by 2, or 7. And now we use our formula. The circumference is 2 pi r. Substitute in now for r 7, and 2 times 7 is 14, so our answer is 14 pi inches. There is another formula, by the way, that simply says the circumference equals the diameter times pi. And if that were the case, we could have used that and said, oh, that's 14 pi as well. And you can use either one. I have a habit of just remembering 2 pi r and always taking my diameter and dividing it by 2. But you could use that equation as well. In problems 3 and 4, we're asked to find the area of the circle in terms of pi. And in these cases, the area is always in terms of radius. So like in our first question, we have 4/5 of an inch, but we need the radius, okay? We need to find out how much is the radius. Well, the radius is half of the diameter. So half of 4.5, or 4/5, 4/5 is 2/5. And now our equation for the area is the area equals pi r squared. So now we're going to take our radius here and plug it in for the r, for the radius. So we have pi times 2/5 squared. So 2/5 times 2/5 is going to be 4/25 pi, and that's our answer. Remember that when you multiply fractions, 2/5 times 2/5, you multiply the numerators, 2 times 2 is 4, and you multiply the denominators, 4/25. On the next one, they give us the radius, so we don't have to do that calculation. So the area is pi r squared, so we put 10.5 in for that, and then 10.5 squared is 110.25 pi meters squared. Notice again on both of these, our units are square because we're doing area, all right? And if you wonder where that comes from, this is 10.5 meters times 10.5 meters. So meters times meters is meters squared. Your area will always be a square unit. Your circumference and your perimeter will always be a regular unit. In our next two problems, we're going to find both the circumference and the area. And then we're also not going to leave it in terms of pi, but we're actually going to make an approximation by putting in the approximate value of pi, which is 3.14. In our first one, it says that the radius is 6 meters. So the circumference is 2 pi r. So we just simply substitute in 6 for r, which means that our circumference is, in terms of pi, 12 pi. But now we're going to put in 3.14 for pi to give us an approximation. And we end up with the number 3.768. Now, you remember to round off to the nearest tenth, I simply go to the tenth here. I look next door, and I see that is that number bigger than 5 or less than 5? It's bigger than 5, so we round up from 6 to 7. And so our final answer as an approximation is 37.7 meters is our approximate circumference of the circle. Now for the area, we use the area equation. Area equals pi r squared. Again, we plug in 6, so we get 36 pi. Once again, we'll put in 3.14 for pi, and we get 113.04. Again, we're going to round off. We'll go to the 10th spot. We look next door. This time the 4 is less than 5, so we do not round up. We simply leave it at 0, and our answer is 113.0 meters squared. Now the same thing for number 6, except for number 6 is giving us a diameter. So the first thing we want to do is find the radius. So the radius is half of the diameter. So 3.4 divided by 2 is 1.7. And now we do exactly with that what we did in problem 5. Plug it into the formula. Circumference equals 2 pi r. Put in the 1.5, 1.7 into that equation. And we end up with 3.4 pi. And again, let's insert pi as 3.14. And we end up with a number that is 10.676. Again, go to the 10th place, look at that number, and then go next door. Is that greater than 5? It is, so we round up to 10.7. And then let's move and find the area. Area is pi r squared, so we substitute in 1.7. 1.7 squared is 2.89 pi inches squared. And now we'll plug in the 3.14. And you see that that's 9.07, so go to the 10th place again. Look next door, that's a 7, so we round up to 9.1. Problem 7 asks us to find the area of the shaded region. We had a problem like this in our previous homework, and our strategy is simply going to be, let's find the area of the large circle and the small circle, and then we'll subtract the small circle from the large circle to find the shaded area. So let's get started. First thing, in both of these circles, we're given the diameter. So we need to find the radius. Remember that the radius is half of the diameter. So for the large one, which is 100 millimeters diameter, half of that will be 50 millimeters. For the smaller circle, half of 40 millimeters is 20 millimeters. So these are our radius. And now we can find the area. The large circle is going to be pi r squared, which is now going to be pi times 50 squared, or 2,500 pi millimeters squared. The small circle, similarly, is going to be pi times 20 squared, or 400 pi millimeters squared. So in this case, let's subtract the small circle from the large circle, and we get 2,500 minus 400 pi, or 2,100 pi millimeters squared, and that's our answer. Problem 8 says that we have a square and a rectangle that have equal areas. Then it gives us the dimensions of the rectangle, that it's 50 centimeters by 98 centimeters, and it wants to know what is the perimeter of the square. So our strategy is we can use the dimensions here to find the area of the rectangle, which will give us the area of the square, and then we can work from there to find the sides. But remember, we're looking for the perimeter, so don't forget what our final question is. So the area of the rectangle, base times height, is 50 times 98, which is going to be 4,900 centimeters squared. Now the problem tells us that that's the same area as a square. Remember, the square, because each of the sides are the same, means that the area is a side times a side, base times height, side squared. So this implies that if side squared is 4,900, then the side must be the square root of 4,900, which is 70. You can think of this, if you weren't sure there, you can remember that this is 49 times 100, 4,900, and the square root of 49, so you see the square root of 49 times the square root of 100, and that's 7 times 10. So we now know that our side is 70 centimeters, so now we can find the perimeter. Remember, the perimeter is 4 sides, side, 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 side. So 4 times 70 is going to be 280 centimeters, and that's our perimeter. Problem 9 asks us to graph and label a triangle with the given vertices and then calculate the side lengths, the perimeter, and the area. This is an important problem because you'll have one exactly like it on the test. The first part, to graph, remember that in a coordinate pair, the first number is the x and the second is the y. So like if I'm graphing point A, I always start at the origin, right here. The x is -1, so that means I go to the left 1. And then y is +4, so I go up 4. And there's my point. There's A. For B, again, the x and the y. B says x is -1 again, so I come over 1. This time I go down 4. And there's my B. And then finally point C says x is 5, y is -4. So here I go over 5, 1, 2, 3, 4, 5, and then we go down 4 to find C. And then we connect the lines to draw a triangle. Now to find the 3 sides, 2 of them are very easy because they're horizontal and vertical lines. For example, AB, I can simply count the squares here. 1, 2, 3, 4, 5, 6, 7, 8. Or I can subtract the y components here. See, 4 minus -4. Remember, the subtracting a negative is the same as adding the positive. So 4 minus 4 is the same as 4 plus 4. Gives me the 8 that I saw there before. So this side is 8. And then the same thing I can do for BC. I could just count the squares. 1, 2, 3, 4, 5, 6. Or I can this time subtract the x's. In other words, I have 5 minus -1, which is 5 plus 1, or 6. So my bottom is 6. Now when it comes to AC, I have a diagonal line, so I can't count squares. So now we're going to simply have to use our Pythagorean theorem. A squared plus B squared equals C squared. So in this case, I know that 8 squared plus 6 squared, the 2 sides of the right triangle here, equal my length, the square root of that. So 64 plus 36, or square root of 100 is 10. So now I know that this side is 10. By the way, some of you should have realized this is simply a 3, 4, 5 triangle. All we did is multiply everything by 2. 2 times that gave us 6, 8, 10. So one of those triangles you should expect to see often, the 3, 4, 5 triangle. Now we have everything we need. The perimeter, we just add up the 3 sides. So we're going to add up 8 and 6 and 10, and we end up with 24 units. The area of a triangle is 1/2 the base times the height. So 6 times 8 is 48 divided by 2 is going to be 24 units. Notice these answers are not the same. This is 24 units. That's a distance around. This is how many squares, units squared, that we always use for area. Problem 10 asks us to compare and contrast. Your friend can't remember whether 2 pi r, he says that's one of those formulas, whether it's the circumference or the area. Well, my hint for you would be to think about the units, all right? So if I have 2 pi r, and let's suppose I say that the radius is 5 inches, well, that would be 2 pi times 5 inches, okay? So if I multiply that out, I end up with 10 pi and just 1 inch. Well, remember the difference between circumference implies a length, whereas area implies how many squares do you have. So area always has squares. So in other words, circumference would be inches, but area would be inches squared. So in this case, we can conclude then, since the 2 pi r only has one variable, it must compute the circumference. pi r squared, you see, would give us r squared or inches squared. So in this case, 2 pi r is the formula for circumference. Our last problem has to do with error analysis. A classmate finds that the area of a circle with a radius of 30 to be 900 inches squared. What error did your classmate make? Well, let me give you a hint here. Think about this. What happened to the pi? Remember that the area is pi r squared. And what our classmate's done is he's taken the 30 and squared it. 30 times 30 is 900, but he forgot the pi. So the correct answer is pi times 30 squared, 900 pi, or about 27.4 inches squared. But notice right here, this is what's missing. He dropped the pi. He just did the r squared and forgot to put the pi. All right. Hope that helps you with the homework tonight. Have a great day.